Okay, let's look at oxyacids. Now, oxyacids are the case where the hydrogen will be bonded to an oxyanion. And just to kind of remind you what an oxyanion is, it's simply a polyatomic ion that has oxygen in it. So nitrate, sulfate, phosphate, all of these are oxyanions. If I was to add a hydrogen to these, I would end up with nitric acid, sulfuric acid, phosphoric acid. And the main point of all of this is that when you draw your Lewis structure for oxyacids, the hydrogen will not be bonded to the central nonmetal, nitrogen, sulfur, phosphorus. It'll be bonded to the oxygens. So let's do nitric acid as an example. HNO3. So we have 1 valence electron for the hydrogen, 5 for the nitrogen, 3 oxygens with 6 each, so that gives us 24 electrons. Now, when you go to draw the Lewis structure, we'll put the oxygens on the nitrogen, and it's going to be tempting for you to put the hydrogen on the nitrogen. It would seem like that would be the way it would be. Nitrogen needs 4 bonds, and so why wouldn't we put the oxygen here? Well, that's not the way an oxyacid works. For an oxyacid, the hydrogen will be bonded to an oxygen. Now, it doesn't matter which one you choose to bond it to or how you draw it. It just needs to be bonded to the oxygen. Then we need to complete the octet. However, we'll have a little bit of a problem here. So now each of the outer atoms is surrounded by 8, and we would want to put another lone pair on the nitrogen to complete its octet, except we have now run out of electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We only have 24 electrons, so that means in order for the nitrogen to be surrounded by 8, I'm going to have to take one of the lone pairs off of one of the oxygens and make an additional shared pair, so the nitrogen is going to be double bonded to one of the oxygens. However, when you do this, you're not going to want to pick the oxygen that already has the hydrogen bonded to it. You want to pick one of the other oxygens. So I will take this lone pair here and make it an additional shared pair here. And so rewriting it, I have a double bonded oxygen, a single bonded oxygen that has a hydrogen bonded to it, and then another oxygen. Completing the octet for the oxygens. And that would be it. Every atom is surrounded by 8, except for hydrogen, and I've used exactly 24 electrons. Okay, let's do a couple more oxyacids. About chloric acid and carbonic acid. Now for chloric acid, let me just go ahead and add them together here. It's 26. And over here it'll be 24. Now when I connect all the atoms to a central atom, I could choose either chlorine or oxygen. Now remember, symmetry is almost always the way to go. So even though putting chlorine in the center should go against the grain a little bit because it violates the Honk rule, it's the only choice to maintain symmetry. Now again, the Honk rule is really a good map for most Lewis structures, but it's not always the case. So there are exceptions, as you've already seen. So this would be another example of an exception to the Honk rule. Now the Honk rule, really, it's more if you have choices, go with the Honk rule. But if you don't have a choice, which we don't have here, well then, live with it. Okay, so now, because it's an oxyacid, The hydrogen will be bonded to one of the oxygens. Again, it doesn't matter which one I choose or how I draw it. I could have drawn this hydrogen over here. Doesn't matter. And then complete the octet on the oxygens. And now, to complete the octet on the chlorine, I need to make sure I have enough electrons. Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I have 2 more electrons, and so I can go ahead and put in a lone pair on the chlorine. So I have every atom surrounded by 8. It's an oxyacid, and the hydrogen is bonded to the oxygen. Okay, now for carbonate, now if you want, you kind of have enough, you've seen enough already, you might try to do this one yourself. So why don't you pause the video, see if you can do it, and then come back and I'll walk you through it. And 3, 2, 1, I will walk you through it. So carbon's going to be in the center. And you have 2 hydrogens. Now the hydrogens, you want to spread things out. If you just did it and you put both the hydrogens on the same oxygen, again, you think symmetry, you want things spread out. So if you were to have both hydrogens on the same oxygen, things are kind of lopsided. So I'll put 1 hydrogen over here and 1 hydrogen over here. And then I'll complete the octet on the oxygens. But before I put 2 dots on the carbon, remember carbon is going to have 4 bonds. So if I put dots here, that would be a violation of that. And we don't have 2 more electrons. This is 24 electrons. So in order for the carbon to have an additional bond, or to have 8 electrons, it's going to need an additional bond. It's going to need to have a double bond with one of the oxygens. But when you do that, don't pick the oxygens that already have hydrogen bonded to them. Pick the other oxygen. So this oxygen, one of the lone pairs, will form an additional shared pair with the carbon. So let me rewrite it down here. So now every atom is surrounded by 8, and we've used 24 electrons. Okay, boron is an exception to the octet rule. If we were to look at boron trihydride, you can see immediately we're going to have a problem. Boron has 3 valence electrons, and each of the hydrogens have 1, so we only have 6 electrons. So when we draw our Lewis structure, once we have the 3 hydrogens bonded to boron, we're out of luck. As far as the octet rule is concerned, we have no more electrons. But for boron, that's okay. This is an exception to the octet rule. Phosphorus and sulfur are exceptions. Again, I'm just picking a simple example. So I'll say phosphorus pentahydride. So phosphorus has 5 valence electrons, and each of the hydrogens have 1, so it gives us 10. So when we draw our Lewis structure, we'll find that the phosphorus is going to have to bond to all 5 of the hydrogens. Remember, hydrogen can only have 1 bond, and so it would look something like this. 5 hydrogens. Sulfur can have 6 bonds around it. Let's look at sulfur hexahydride. So we have 12 electrons, and for it, we'll have 6 bonds on the sulfur. Now don't go running to these exceptions, boron before or phosphorus and sulfur here, to build your Lewis structure. This would be only when nothing else works.